All right, so this video begins our instruction on inequalities. Inequalities are actually very, very similar to equations. It's just they're going to have a less than or equal to, a greater than or greater than equal symbol in there. So the first thing we're going to talk about is how we actually solve these. You too. So we're going to be solving these equations, these inequalities, just like we would equations. So on our first problem, pretend like this is an equal sign. It's not, but we're going to pretend like it is. So this is a plus 9, which is 3x equals 27, and then divide both sides by 3. So x doesn't equal, it is less than or equal to 9. So what that means is that any value of x that is less than or equal to 9 is okay. So we're going to go to our number line, and we're going to put a dot on 9, and we're going to shade everything that is less than 9. Because what that means is that any of these values that I just shade, if I plug it in the equation, it will work. So we're going to pick a test value, and it can be any one of these numbers here. I usually try to pick 0 if it's in my shaded area because it's really easy to plug in. So I'm going to plug it in here. 3 times 0 minus 9 should be less than or equal to 18. 3 times 0 is 0. 0 minus 9 is negative 9. Is negative 9 less than or equal to 18? Yes. All right, so the next one I'm going to work just like an equation, but I'm not actually going to trade it out for the equal sign like I did over here because I don't want you to get used to that. So on this one, again, this is like my equal sign, okay? So if you need to draw a line down there, that's fine, but you want to make sure that you can still tell what your symbol is. So I have a minus 1, so I need to add 1 to both sides. And then I've got 6w is less than negative 12. Dividing by 6 gives me w is less than negative 2. So any value less than negative 2 is okay. Now, did you notice that this one is just less than, not less than or equal to? So that means we can have anything less than negative 2, but not exactly negative 2. That's different from the one we did over here because we could have plugged in the value of 9 and it was okay because 9 is equal to 9. But this time we can only have less than. So the way that we mark that when we do it on a number line is we draw an open circle. Meaning I can't have that, but I can have anything right up to that. So, and again, I want to shade everything in the less than direction because any of those values will work. Now for my test value, 0 is not in my solution set, so I actually have to choose something else. I'm just going to pick, say, negative 4. So 6 times negative 4 minus 1 is less than negative 13. 6 times negative 4 is negative 24. I'm running out of room. Let me rewrite real quick. Okay, so again, this is negative 24 minus 1. And negative 24 and negative 1 is negative 25. Is negative 25 less than negative 13? Yes, because negative 25 falls further that direction on the number line than negative 13 does. All right, let's try another one. All right, so on this next problem, we're actually going to change it a little bit. You're going to learn about how to deal with negatives in front of a variable next year. But for now, we're just going to do 2 plus 1/2 b is less than 5. So I'm going to do the same thing and subtract 2 from both sides. That's going to give me 1/2 b is less than 3. Now, to get rid of a 1/2, I can multiply by 2. And the reason is because 2 times 1/2, remember, multiply the tops, multiply the bottoms, and simplify just gives me 1. So really, it makes it go away. And I've got b is less than, don't forget to multiply the other side, 6. So on that, again, it's a less than, so this should be an open circle at 6, and I want everything that is less than that. Got a lot of less thans on this one. So 0 is in my solution set, so I'm going to choose that to test. So that's going to give me 2 plus 0, and 2 is less than 5. That is true, so that means my solution set is correct. On our next problem, we're actually going to do the exact same thing. We're going to change that negative out. And I'm going to add 2.1 to both sides. Oops, sorry. And that's going to give me 0.3p is less than or equal to. Now, remember how to deal with your integers. You have more negatives than you have positives, which means your answer is going to be negative. But you've got to figure out the difference between the two. So this is 5 and 1, so we've got a negative 1.5. Then going to divide by 0.3. This is also a good review of how to divide with decimals. You're not allowed to have decimals on the outside, so you have to move it over, which is the same thing as multiplying by 10, which really just means we're dividing 3 into 15. So it's going to give us p is less than or equal to 5. And that's a negative because, remember, it takes 2 negatives to make a positive. This one is actually a less than or equal to as well. It is going to be closed, and it starts at negative 5. And everything less than that gets shaded. Now, I know we didn't have one on here, and it's because I actually switched those problems out. But if you ended up with something that was, say, x is greater than 4, then you would go to 4, put an open circle, and then just shade in the opposite direction. So greater is at the increasing, less than is at the decreasing side. So let's pick our last test point to make sure it works. 0 is not in my solution set, so I cannot choose that. So I'm going to choose negative 6. So I've got 0.3 times negative 6 minus 2.1 is less than, I think that was 3.6. Negative 3.6. Do some erasing so things don't get too confusing. All right, so I have to do this first, which gives me negative 0.18, and that's minus 2.1, and I want that less than or equal to negative 3.6. So combining these two, 2.1, 0.18, and I've got negative 2.28. It's less than or equal to negative 3.6. And let me see, I think I've actually made a mistake here. Oh, I'm sorry. I got to go all the way back. 0.3 times negative 6 is negative 1.8. I had it the other way around. So then I've got 1.8 plus 2.1, which gives me negative 3.9. Because again, negatives with more negatives give me a bigger negative. And now I can look at this and say, okay, is negative 3.9 less than or equal to negative 3.6? And that is true because this falls further left on the number line than this guy does. So yes, it is true. So we're actually going to, because we changed some things, these questions at the bottom don't really apply anymore. So we're actually going to skip that. But mainly what you should have gotten from this video is that as you look at these problems, you're going to treat them just like a normal equation. It's just when you get down to the end, we're going to shade it on a number line because there's more than one solution. And always pick a test value to check your work. All right, please complete the practice pages that follow in your workbook.